class. My name is Dave, and in this video we're going to talk about .NET class library, the .NET class library. I've alluded to it a few times throughout these video series. We talked a good bit about the built-in data types. One of the first videos we talked about data types. There are different types of data. And C# has built-in data types, the string, int, double, boolean. These are built into C#. Remember the blue indicates that it's built into C#. So those are the built-in data types, and there aren't many of those. There are only a handful of those. But there are thousands and thousands of other data types that are in the .NET class library. These are custom data types, or you can call them complex data types. They all use some of those built-in data types, one or more of those built-in data types. If you look at any complex data type, you'll see strings and integers and doubles and booleans. You're going to see these built-in. So you can think of those built-in data types as building blocks for creating more complex data types, right? Or custom data types. And you can create your own data types, which will, when we get into object-oriented programming, we'll create our own data types, which you can do. And a lot of other programmers create data types. These are third-party data types that, if we had internet, you could download these third-party types. But the .NET class library, that is the library that comes with the .NET framework, right? Remember, the .NET framework is what the program is running on. It's the framework that the program is running on. And there are two main parts to it. One is the CLR, Common Language Runtime, the CLR. This is what manages the memory, right? We've talked about the memory variables and memory boxes and memories, and we got to have something managing all that, right, behind the scenes, and that's what the CLR does. So it does a lot of things. That's sort of the brains of the outfit, if you will, the CLR that manages everything. The other part of the .NET framework is its class library. And by the way, classes are one way to create a data type. It's the main way to create a data type. And we'll see that when we get into object-oriented programming. So I wouldn't worry too much about what a class is right now. We're going to talk about that a lot when we get to object-oriented programming. So for right now, just know that class is a blueprint. Is a blueprint for creating another type of data, or a complex or custom type of data. And in the .NET class library, there are thousands upon thousands, I have no idea how many. There are a bunch of data types, custom data types, or complex data types, whatever term you want to use, in this .NET class library. It's a library of custom data types, right? It's a library of custom data types. And I'm assuming all these data types were created by these geeks at Microsoft. I don't know. I guess they have teams at Microsoft that put these types together. And they're only using the fundamentals, all these types. If you look at the code in these types, which we actually can't, but if you did, you would see for loops and variables, and you would see strings and booleans, you would see lists and arrays, you would see all these fundamentals that we've covered here. And that's what they're using to create these complex types, or these custom types, right? So, the fundamentals that we've learned so far, that goes into creating a custom data type, right? And if it's not clear what I mean by data type, we're going to see examples. And when we get into object-oriented programming, when you get a good grasp of that, then you'll understand that, maybe have a better understanding. So I know some of this may be a little fuzzy, but that's okay. That's okay, because we haven't got into object-oriented programming, but we will later on. So right now, just as long as you know that the .NET class library has a bunch of data types, right? And it's just different types of data. There's different types of data. Each of these data types have members, right? Have members. They have properties and methods. Right? Methods just do something. Property just holds data, right? Just like a variable. It's like a box, right? Same idea, same, right? There are other types of members, but we're just going to focus on those for right now. So let's look at some of just a handful of the types. And there are thousands, a bunch of them, so we can't cover all of them, obviously. But we're just going to cover just a handful, just to give you an idea. So let's look at this first example. This is using something called, but this is called the date time. This is the date time. This is a type in the .NET class library that you're welcome to use. Anytime you need, it'll take a wild guess at what it does. It gets the date and time, right? So we've used this before. So it just gets the date and time. And these are its members. Play around with these members. I strongly recommend just type in period, and you can see the members, right? You can click on each one, and it will give you a little synopsis of what it's about. It'll tell you the data type that it's going to give you, that it's going to return. It gives you a description, right? If it's a method, it'll give you its parameters. What type of data, what kind of data do you need to pass to this method? Again, we're going to talk about methods later on, so if it's not clear what a parameter is, don't sweat it. So these are all methods. How do I know that these are methods? Because of the little purple box, right? The little purple box thingy, that symbolizes a method. And what does a method do? It does something, right? It just does something. So, and sometimes it returns something, not always. If it says void here, it means it doesn't return anything. So generally a method will take data that you pass to it, do something, and return you a value. But not necessarily. It may just do something and not return a value. So, and we'll talk about methods later on. So, but this has properties. The now gives you the date and time now, right? Whatever the date and time is right now, that's what it gives you, right? And it returns a date time object, or a date time type. That's the type of data it returns. A data type is a type of data, just like a string, an int, a double, a bool. It's a type of data. It's a type of data, right? And it has members. All data types have members, right? And these are its members. We access its members through the period, through the dot. The member access operator is the fancy term for that dot. You just call it a dot, but the fancy term is member access operator. We're accessing its members, right? So again, this little icon indicates a property. The purple box indicates a method. A property holds data. A method does something, right? So the .NET class library holds a lot of these data types, and you can use any of these data types. And so the period is how we access its members, right? That's how we access its members. And we do the same thing here. Type in the dot period, and we access its members, right? This is a date time thing, a type, right? And the now has members. And you see, you can have a long date string, to local time. These are all methods. To local string time, or to long time string, whatever. The year. This is a property. And with properties, you don't need the parentheses, right? With methods, you do. Methods, you always need parentheses. This is how we pass values to a method, right? So you need to have those parentheses, whether you're passing a value to it or not. In some methods, you don't pass values to, and this one you don't. It just does something and gives you something back, right? So, but whether you're passing a value to a method or not, you still have to have these parentheses. You always have to have these parentheses when you're calling a method, right? Like the purple box, right? The purple box indicates a method. So if you're going to call a method, invoke a method, call a method, run the method, you got to have these parentheses, whether you're passing it a value or not. With a property, you do not need parentheses, and it'll bark at you if you have parentheses, right? So either way, in Visual Studio is going to bark at you it'll give you the red squiggly, if it's not right. So the now also has its members, and I strongly recommend, again, just playing around with this. The best way to learn computer programming is just to play around with it. Just it's not going to blow up. Hopefully, it won't blow up. So you just type period, see what this does. Click on this and read the synopsis. And just use it. Run the method, call the method, and see what it does. Right. Just play around with it. It's really the best way, because there's so much to cover here. I can't possibly cover most of this, or I can't cover a lot of this. I can only give you the basic idea and get you started, and that's the whole point here. I just want to give you a foundation and get you started, right? So this now has its members. One of its members is this too long date string. It's a method, right? The purple box, a method, and it gives me a string. It returns a string. So I can assign that string that it returns to me. It's a method. It does something. It returns a string. I know it returns a string because it says string, right? So it returns a string. And I can assign the string to this text property. This text property holds a string, right? So this returns a string. This holds a string. Bingo, right? So I can assign this string to this text property. And so let's see what happens. This is a label. I have a format, by the way. And I have one button and one label. Just like we've done before. So I have one button, one label. I have the code and the click event, right? Double clicked on the button, right? Just like we've done before. So I'm going to click on this button, and here we see it gives me, that's what the long, too long date string. There are different formats. You can play around with that, but this is what the too long date string gives you, right? It just gives you the date in that format, right? So we can see the design. I have one button, one label, have a format. I've double clicked on this button to set up the click event, right? So, okay, so that's the date time, and again, just recommend just playing around with that. And by the way, we call these static. This is a static class. Don't worry about what that means. I don't want to delve into what that means. But this, we don't have to. Well, let's keep rolling because there's too much to explain there. So let's keep going. So some types you put a dot here, and it's going to give you the members, and it may have methods and properties. And other types we have to instantiate, right? Is the big fancy technical term, instantiate. That makes no sense, so that's fine. Don't worry about it. This one is one we have to instantiate, right? The big complex, very complicated sounding term. It basically just means make a thing, It just make a thing out of this type, right? So that probably makes no sense. So that's fine. Don't worry about it. But just know that with some types we have to use this new keyword. Most types we do. Some types we don't. The date time we don't. And it's probably best just to play around. You'll see. You'll get a feel. The more you play around with this, the more you'll get a feel for which ones you have to instantiate, which ones you don't. But I don't want to get too in depth with this because we're getting off into object-oriented programming, and I don't want to get off into that right now. But just so for some types, you have to use this new keyword that says create a new thing out of this type, right? Out of this type, and so. Okay, so I've created a new we call it an object or an instance. I've created a new instance of this random. This is calling basically a method that sets everything up, called a constructor. So we're creating an instance of this random type and assigning it to this variable that holds a random type. Right, holds a random type. And if this line makes no sense to you, don't sweat it. This is object-oriented programming, and we haven't got there yet. So just know that, just remember the syntax. Just type the syntax in and just go with it. Even if it doesn't make perfect sense to you, that's fine. We're going to come back to that when we get into object-oriented programming. So we've got this variable that holds a random type, and we've created this thing, right? This thing that's of this type, that's of random type, right? And we've assigned it to this variable. So what the random type does is it gets a random integer. And we can see its members doesn't have a lot of members. The main member we use is next, returns an int, right? And it says it returns a non-negative random number, get it back up, less than the specified maximum. Less than the this is the max. This is the start number. This is the maximum. Okay, so the next method it gets a random integer within this range. The start number is this is the start number. This is the stop number. So it's within this range from 1 to 1,000. But it goes up to but not including 1,000. So it's actually 1 through 999. If you don't have a start number, and you can also do it this way, just give it a maximum number, then it's going to start at 0. So this says give me a random number from 0 through 999. Give me a random integer from 0 through 999. It goes up to but not including this max number, the stop number. So that's if you don't give it a start number. Let's go ahead and give it a start number. So now the range is from 1 through 999. We're up to but not including this number. So up to but not including that number. So it's 1 through 999 in this case, right? So if this was 55, then it would be 1 through 54, right? So up to but not including this number. So let's go with 1,000. And let's just set a breaking point right here. Actually, let's go ahead and assign this to our label. Okay, so this returns an integer, right? So I've assigned this variable, this box, right, as integer. You can only take an integer type. And like we've done several times before, we have to convert that integer to a string in order to assign it to this text property, because it only holds a string, so we can't put a number in there. It's going to bark at us. It's like putting dirty socks in a box that can only take food, right? So we have to convert it to a string, plain text, and now we can assign it to this text property. So let's see what happens. Alright, so click the button, and there we go. We got a random number from 1 through 999. And it's just going to keep getting, every time I click the button, it's going to execute this code. And it's only, the rest of it's commented out, so it's going to execute these 3 lines. So it gets a thing, an instance of this random type. Again, if that makes no sense, that's okay. We haven't covered object-oriented programming. And this isn't going to make perfect sense until we really delve into object-oriented programming. So for right now, just go with it. Just learn the syntax and just kind of go with it. So this new keyword, create an instance of this type. Give me an instance of this type. All right. And by the way, it's the same when you create a string. It's the same thing. It's the same thing. It's just you don't need this. It's a built-in type, so you can omit this. You don't need it. But it's basically the same sort of thing. So you're creating a new string or a new int, right? Same, but you just don't need this with those built-in types. So we're creating a new instance of this random type, assigning it to this variable that only holds a random type, right? This box in the computer's memory, you only put a random type in there. You try to put a string in there, it's going to bark at you. You try to put an int in there, it's going to bark at you. You can only put a random type. So this creates me an instance of that random type and drops it in this box. Again, if that makes no sense, let's keep rolling. That's okay. We're going to talk about object-oriented programming down the road. So one of its members, the random type, is a method called next. And the next returns an int, right? And it returns a random number within a specified range. A random number within a specified range. This is the start number. This is the stop number. It goes up to, but not including that stop number. So it's never going to get 1,000, right? It may get 999, but it's never going to get 1,000. So up to, but not including that stop number, right? So every time I click this button, it's executing this code, and it's getting a random number, a random integer, assigning it to this variable, and then we just convert that integer to a string and assign it to this text property on this label, right? And it's going to do this every time. So this is good for games. If you need a random value, it comes in handy. Okay, so another type, and this is static, right? It's, so we can just type the period here. We don't have to instantiate this. If you have no idea what instantiation means, that's okay. So here we just type the period. You access its members, and there are a bunch of methods in here. These are all math related, obviously. The cosine and the for and all these different tan, these different mathematical operations. So the math it's a class that does that does advanced mathematical operations, right? So one of them is the exponent, the power. So this is basically 10 to the power of 2. 10 to the power of 2, right? That's all it is. So this should be 100, right? 10 times 10, 100. So that's just 10, this number to this power, right? So 10 to the power of 2. That's all this is. So you put in the base number here, and you put in the exponent here. And this is just a method that returns the answer, right? The power of 10 to the power of 2 is going to give you the answer, right? Put it that way. All right, so you click the button, and it's 100, right? So 10 to the power of 2 is 100, right? 10 times 10 is 100. So let's see what 10 to the power of 5 is, right? So that would be 10 times 10 times 10 times 10 times 10, right? 5 times. So there you go. It's whatever that is, or 100, whatever. Okay, so moving right along. So this is the math type. It lives within the .Net class library. Again, I'm just introducing you to the .Net class library. There are thousands and thousands of data types in there that you can use. So we're just covering a handful right now. So let's look at the string builder and take a wild guess at what the string builder class does. Just take a wild guess. It builds strings, right? It just builds strings. That's all it does. And there's a bunch of different, well, maybe not a bunch, but there's a different methods, has different members, has a few properties and a few methods. Append, you just add to the string. So you're just building a string, right? And again, I strongly recommend that you just play around with this. Just play around with it and see what it does. And so I'm create this one. I have to create an instance of this string builder type, where I have to create this thing, this instance of that type. So I've got this variable that can only hold this type. So, and the string builder is not of string type; it's of string builder type, right? So I still have to convert it to a string. It builds a string, but I still have to convert it to a string in order to assign it to this text property that only holds a string, right? So let's go ahead and run this. I'm appending each one of these strings to my string builder, and there you go, 1, 2, 3. So I've appended, just add this string, and just adding these strings to the string builder, and then I convert that to a string and assign it to this text property that labels. So it's a convenient way to build strings. Remember, before we used the concatenation, you could also do it this way, and it may be easier to do it this way. So it's another way to build a string. You don't have to use it. You can just use the plus sign, concatenate. That's fine. But this is just a nice, convenient way to build strings, right? Okay, so that's the string builder type, the .NET class library. And you also have this string with a capital S, so uppercase S. And this is exactly the same as the lowercase s. It's the same, exactly the same. Actually, it's the same class, same everything, same. But this one, the uppercase, note the teal color, right? The teal color, which represents, it's in the .NET framework, right? The blue color indicates that it's built into C#. So, but the string with a uppercase S, exactly the same as the string with a lowercase. Same. You can use either one. It doesn't matter which one you use. I generally use the one with the lowercase. Doesn't matter, right? So same. So if you see the uppercase S, what's the difference between the lowercase and the uppercase? Same. There is no difference, right? So let's go ahead. Let's run this. So this is exactly the same as we've seen before. Just want to point out that there's a string that's within the string data type, that's within the .NET framework, and there's also one that's built into C#, right? And same thing with int, and this is actually int32, not just int. It's int32, and we'll see this is same. Just like an int, same thing. So this just lives within the .NET class library, and same thing with double. I'm not going to run this, but the same thing with the double. This is double with a capital D. It's the double type that lives in the .NET class library. All right, the one with the lowercase lives in is just built into C#, right? So let's look at the color type. And what do you think the color type does? It gives you colors, right? So this is one way to get colors. This is actually a struct. You have no idea what a struct is. That's okay. Don't worry about it. We'll come back to that. So the struct the color just gives you different colors, right? There are all these different colors in here. And this is one way. This is how you can change colors of the controls programmatically through the code, accessing it through the code. And the property that we're going to change, we've mostly been changing the text property of these labels, but you can also change the back color, right? The back color, and that just changes the back color, right? So let's go ahead and run this. So we're going to change it to forest green, right? So when I click the button, this label, the background should change to forest green, and there you go. So I just changed the color programmatically through the code. I changed the color as opposed to the GUI, right? The graphical user interface, and the properties grid. I can change it here. Here's that property, the same property. Yeah, I can change it here, right? I have some custom colors, different colors here, and colors here, so so you can change it here, or and also you can change it through the code, right? So that's the color type, and again, this is a type that lives in the .NET framework as opposed to being built into C#. So it's just another type in the .NET framework that you can use. And this last one, message box, this is again another type. It's a data type that resides in the .NET framework. And we've seen this several times before. It just throws up a dialog box, right? So we click on the button and we see the dialog box, and we just pass it the string that we want to put in there. You can also put a caption in here if you want, which is a string. Right, I'll just put caption there. And we see the caption, it goes up here, right? So whatever you want up here, you just put that as the second argument, right? So this is the second argument is the caption. So there you go. There's just a brief overview of the .NET class library. There are a bunch of types in there. We're going to see a lot of them. These are just a handful. So that's it for this video, and I'll see you in the next.